Hello students, welcome to EPG Pathshala. I am Dr. Ayushi Paliwal from University of Delhi. Today we are going to discuss about the module power supply from the paper electronics. So students, let us see what we are going to learn in this module. First, we will discuss about the various components of power supply. Second, basic types of filters will be discussed. Third, voltage regulator will be discussed in detail. Next, we will also discuss about two types of voltage regulation, line and load. Lastly, linear regulated power supply will be discussed in detail. So students, let us start with a basic introduction about the module. Power supply is a broad term that generates a fixed or controllable magnitude DC voltage from the available form of input voltage. Integrated circuits IC chips used in electronic circuits need standard DC voltage of fixed magnitude, which needs well-regulated DC supply for their proper operations. In majority of the cases, the regulated voltages are of magnitudes varying between -18 to +18 volts. The digital ICs may need 3.3 volt supply, and the hard disk driver or the floppy driver may need plus minus volts and plus minus 12 volt supplies. So the individual output voltages from the multiple power supply may have different current ratings and different regulation requirements. Almost invariably, these outputs are isolated DC voltages where the DC output is ohmically isolated from the input supply. In the case of multiple output supplies, ohmic isolation between two or more outputs may be desired. The input connection to these power supplies is often taken from the standard utility power plug point. It may not be unusual, though, to have a power supply working from any other voltage level, which could be of either AC or DC type. Power supply. Power supply is a device which converts, regulates, and transmits required power to the circuit to be operated. So, following are the reasons for the need of power supply. First, all electronic circuits need smooth DC power supply in order to function correctly. Second, DC power supplied either from the battery or power pack units. Third, battery power supply may not be economical. Fourth, some other circuits, those using digital ICs, also need their power supply to be regulated. So students, this figure shows the block diagram of a power supply which has the basic elements as first transformer, second rectifier, then we have a filter, and lastly the voltage regulator. Let us now discuss the each element of a power supply one by one. First, let us discuss about the transformer. The transformer is a device which is used to convert the AC line voltage to a voltage level more appropriate to the needs of circuit to be operated. At the same time, transformer provides electrical isolation between the AC line and the circuit to be operated. So the output of a transformer is still an AC voltage, but now of an appropriate magnitude for the circuit to be powered. So this figure shows a transformer where we have a primary circuit and a secondary circuit. Now let us discuss about the rectifiers. A sinusoidal signal has both the positive and negative values as shown in this figure. Thus, average value of sinusoidal signal VDC turns out to be 0. So we can get non-zero average voltage by removing the negative half cycle of the sinusoidal signal. So a rectifier is an electrical device that converts AC, which periodically reverses the direction, to DC. This process is known as rectification, and it involves a device that only allows one way flow of electrons as shown in this figure. Let us now discuss about the filters. The output after being processed by a full wave rectifier is a pulsating DC. The output contains large fluctuations in voltages. So the power supply that we intend to design must not have any variation in output voltage. So the voltage that we get from full wave rectifier fluctuates between 0 volts and V peak, and hence it contains AC components. These AC components needs to be filtered out so as to obtain DC voltage. This is where filters comes into the picture. So filters, as the name suggests, filters out any AC component present and provides DC as the output. However, the output from the filter is still not a pure DC, but filters remove the AC component in the voltage to a considerable extent. This increases the average DC value of the output voltage. Let us discuss about the basic types of filters. A filter is in general a combination of passive circuit elements, that is inductor and capacitor, and resistor. Some of the filters are inductor filter, capacitor filter, LC filter, and pi filter. Inductor filter. The circuit diagram of the full wave rectifier with a series inductor filter is shown over here. Now, as the name of the filter circuit suggests, the inductor, that is L, it is connected in series between the rectifier circuit and the load. So here the inductor carries the property of opposing the change in current that flows through it. In other words, the inductor offers high impedance to the ripples and no impedance to the desired DC components. Thus, the ripple components will be eliminated. Now, when the rectifier output current increases above a certain value, energy is stored in it in the form of a magnetic field, and this energy is given up when the output current falls below the average value. Thus, all the sudden changes in the current that occurs in the circuit will be smoothened by placing the inductor in series between the rectifier and the load. So the waveform over here shows the use of inductor in the circuit, and it shows the difference between the rectifier output, which is shown by the dotted line, and the filtered output. Now, as we know, the ripple factor, it is given by Vrms by Vtc. So in this case, it is equal to RL by 3 root 2 omega L. Now let us discuss about the capacitor filter. A capacitor is used as the filter, and this high value of capacitor is shunted or placed across the load impedance. This capacitor, when placed across a rectifier, gets charged and stores the charged energy during the conduction period. When the rectifier is not conducting, this energy charged by the capacitor is delivered back to the load. Through this energy storage and delivery process, the time duration during which the current flows through the load resistor gets increased and the ripples are decreased by a great amount. So, thus, for the ripple moment, the component with a frequency of f megahertz, the capacitor C will offer a very low impedance. So the value of this impedance can be written as 1 by 2fc. Thus, the DC component of the input signal, along with a few residual ripple components, is only allowed to go through the load resistance RL. So the high amount of ripple components of current gets bypassed through the capacitor. So as you can see over here, there is a difference between the input pulsating DC, which gets filtered after passing through the capacitor, and the ripple factor is given by 1 by 4 root 3 FCRL. Another type of filter is LC filter, where we are combining, that is the combination of inductor in series with the capacitor is connected like this. So in this filter, the ripple factor is directly proportional to the load resistance, whereas in capacitor it is inversely proportional to load resistance. But in this type of filter, it is independent of load resistance. That is, it is given by root 2 by 3 multiplied by 1 by 4 omega square CL. The next type of filter is a pi filter, where we have a combination of capacitor, inductor, capacitor like this, and the ripple factor is given by root 2 XC1 XC2 by XL RL. So the input capacitor C is selected to offer very low reactance and does major filtering. Rest of the filtering action is done by the combination of L and C. Voltage regulator. A regulator is an electrical or electronic device which maintains a constant output voltage irrespective of changes in load current, input voltage, or temperature. So, this figure shows the various types of voltage regulators. So, electronic voltage regulators are found in devices such as computer power supplies, where they stabilize the DC voltages. In an electric power distribution system, voltage regulators may be installed at a substation or along distribution lines so that all customers receive steady voltage independent of how much power is drawn from the line. Fixed voltage regulator. These regulators provide a constant output voltage, and a popular example is 7805 IC, which provides a constant 5 volts output as shown in this figure. So, a fixed voltage regulator can be a positive voltage regulator or a negative voltage regulator. A positive voltage regulator provides with constant positive output voltage. So, this table provides the corresponding voltages provided by the corresponding IC. So, here 7800 series consists of 3-terminal positive voltage regulator with 7 voltage options. These ICs also have internal thermal overload protection and the internal short circuit current limiting. Now students, Zener diode is also an example of fixed voltage regulator which can be used to produce a stabilized voltage output with low ripple under varying load current conditions. So this figure shows the Zener voltage fixed voltage regulator basically, where we apply the DC input voltage from the rectifier and we get the fixed regulated voltage at the output. So here the resistor RS is connected in series with the Zener diode to limit the flow of current through the diode, with the voltage source Vs being connected across the combination. So the stabilized output voltage Vout, which is equal to Vz, is taken across the Zener diode. Now let us discuss about the adjustable voltage regulator. An adjustable voltage regulator is a kind of regulator whose regulated output voltage can be varied over a range. So there are two variations of the same known as positive adjustable voltage regulator and negative adjustable regulator. So the LM317 series is the most commonly used general purpose adjustable voltage regulator, so which is shown in this figure, and this table shows the various devices of LM317 series and the output voltage and the input voltage correspondingly. It can be used in different ways. For example, a fixed positive or negative output voltage regulator, variable output voltage regulator, or switching regulator. Voltage regulation. Now students, there are two types of voltage regulation, that is line and load regulation. The purpose of line regulation is to maintain a nearly constant output voltage when the input voltage varies. So the purpose of load regulation is to maintain a nearly constant output voltage when the load varies. So first, let us discuss about the line regulation, which is schematically shown in this figure. So whenever there is a decrease or increase in the input voltage, which is passed through the voltage regulator, there is no significant change in the output voltage. So a change in the input line voltage does not significantly affect the output voltage of a regulator. Basically, it is the percentage change in the output voltage for a given change in the input voltage. That is, line regulation is equal to delta V out by delta V in multiplied by 100%. The second type is a load regulation, which is schematically shown in this figure. Now, a load regulation is referred as a change in the load current due to varying RL has practically no effect on the output voltage of a regulator. Basically, it is the percentage change in the output voltage from no load NL to full load FL. That is, load regulation is equal to VNL minus VFL divided by VFL multiplied by 100%, where VNL is the no load output voltage and VFL is full load output voltage. In circuit analysis, a short circuit is a connection between two nodes that forces them to be at the same voltage. In an ideal short circuit, this means that there is no resistance and no voltage drop across the short. In real circuits, the result is a connection with almost no resistance. So a short circuit results in a sudden surge of current which can reach several hundred times the working current within milliseconds. So a short circuit can have devastating effects and can lead to some thermal phenomenon. Let us now discuss about the linear regulated power supply. So the circuit shown below schematically represents a linear regulator circuit where a transistor is placed in between the unregulated DC voltage and the desired regulated DC output. So the difference between the instantaneous input voltage and the regulated output voltage is blocked across the collector emitter terminals of the transistor. In such circuits, the lowest instantaneous magnitude of the unregulated DC voltage must be slightly greater than the desired output voltage to allow some voltage for transistor biasing circuit. So the power dissipation in the transistor and the useful output power will be in the ratio of voltage drop across the transistor And the load? So here the control power dissipated in the base drive circuit of the transistor is assumed to be relatively small and is neglected. So the worst case series voltage drop across the transistor may be quite large if the allowed variation in supply magnitude is large. So worst case power dissipation in the transistor will correspond to maximum supply voltage and maximum load condition. Load voltage is assumed to be well regulated. So the efficiency of linear voltage regulator circuits will be quite low when supply voltage is on the higher side of the nominal voltage. So students, let us summarize what we have learnt in this module. First, various components of power supplies were discussed sequentially. Second, basic types of filters, that is L filter, C filter, LC filter and pi filters were discussed. Third, various kinds of voltage regulators were discussed in this module. Next, we discussed about the two types of voltage regulation, that is line regulation and load regulation. Lastly, we discussed about the linear regulated power supply. Thank you.